This is the Enhancing Clinical Practice and Outcome stream of SNOMED CT Expo. And just a reminder, if you're online, questions can be typed in the question answer section. And if you're in the room and want to ask a question, please wait till the end of the presentation and we can use the microphone so that everybody online and the recording can pick up your questions. So I'm pleased to announce, to introduce Phillip Brennan from NHS England, who will be presenting implementing FHIR and the SNOMED CT unified test list to report laboratory test results. Thanks, Phillip. Carry on.
Thank you for that. So welcome everybody. My name is Phillip Brennan. I'm a business analyst. I work at NHS England in the UK. And today I'm going to be talking to you about the use of SNOMED and FHIR for pathology laboratory test reporting. So I work in the NHS England Pathology Standards and Implementation team. I think one of my colleagues, Corinne, was presented as part of this expo. And as a team, we are developing a set of data products based on SNOMED and FHIR. And those products will be used to replace a set of legacy products to improve the flow of lab reports that currently flow between laboratories and GP practices in England. So I'm going to talk about that. I'm going to talk about the existing flows and the replacement products. And we're also going to look at some common design patterns to illustrate our use of FHIR and SNOMED. And then finally, at the end, I'll talk about our proposed implementation approach. So first of all, some context. So in the NHS in England, over 1.12 billion tests are performed every year. That covers primary and secondary care. Our focus today is on primary care, but primary care still covers a significant proportion of that, around about 10%. And there are approximately 120 plus labs in England, at the moment 6,500 GP practices. The other interesting point on that slide is that currently about 1/3 of the clinical information recorded in primary care electronic patient records are lab result related. So all in all, a very significant data flow. Okay, so this slide describes the legacy data products that currently support the flow of lab results from laboratories to GP practices, and then on the right-hand side, the replacement products that they're developing as a team and will implement as a team. So on the left-hand side, the PBCL, that's the pathology bounded code list. That's essentially a set of lab tests coded using READ, V2 and V3. It's not been updated since April 2018, so we've not been able to directly flow new tests using that mechanism. The second point on there is SNOMED CT PBCL concepts. That's a set of SNOMED concepts that are semantically equivalent to the PBCL and we'll currently use. I'll describe that in a bit. And then finally on the left-hand side, the EDIFACT specification. So this is our particular EDIFACT spec, NHS 003, and that's used to carry and define the data structure for lab reports. Flow between labs and GP practices in primary care. So moving to the right-hand side of this slide, we've got new products. So this is another SNOMED set of tests, previously known as the Unified Test List, or UTL. It's essentially a part of SNOMED. It's more granular than the PBCL version of those SNOMED tests. It's fully modeled and it's currently available as two sets. And the final piece there, the FHIR specification, this will be used to replace the EDIFACT specification based on H7 FHIR R4. Okay. Limitations with EDIFACT is that it can only carry read codes, so it's not capable of supporting SNOMED codes, which is obviously not ideal, and because of the restrictions around the PBCL, means we effectively can't flow new codes currently. EDIFACT is very old, as you can see by the syntax on the right-hand side. It's not particularly user-friendly, and as a result, it means that developers, suppliers, acts as a barrier to new market entrants, particularly in the GP practice space, because the technology is so old. Again, not ideal. Second and final example, in fact, specification is a more complex example. So it's a microbiology example. You can see on the left-hand side, contains various report sections and atomic results. Some of those results are nested. Unfortunately, due to the limitations of EDIFACT, we can't carry that as structured atomic results. In effect, the whole body of the report gets carried as a free text block with a single code, as you can see at the top there, to represent the entire test report. So we're not able to flow fully atomic results. This slide illustrates the relationship between the two flavors, if you like, of the SNOMED lab test sets that we have. So the green one is the PBCL list, which is currently used, which we'll talk about on the next slide. And then the red list is the newly developed, more granular set of SNOMED code and concepts. And then on the left-hand side, we've got the relationship with the local codes. Okay, so this slide illustrates the data flow between GP practices and lab systems to illustrate how tests are requested, and then the results are flowed back to the requesting GP practice in primary care. So starting with label number 1, healthcare professional at the GP practice would request a test. Typically, that would involve connecting to a label planning system, which will be hosted by the laboratory. We've simply clicked through integration from the GP system. The AutoCon system will then flow a request to the lab system, the LIMS, using HL7V2 and local lab codes. I mentioned earlier that there are over 120 laboratories in England. Each of those labs have their own set of test codes, local test codes. So, I want blood cell count in one lab may be coded completely differently in another lab, which is not an ideal situation, clearly. Following the diagram through to label 3 there, once the result and the report is available to report, it's issued by the LIMS, and then it flows into some middleware. And that middleware does 2 key things. It transforms the HL7V2 output from the lab system into the EDIFACT standard I've talked about previously, and it also maps the local lab codes to the PBCL codes. The data then transported using some national infrastructure called Mesh back to the GP system, and then obviously in the GP system, the recodes are mapped to the SNOMED equivalent codes using that PBCL SNOMED list I mentioned. So all 3 different sets of coding schemes to support the same test results. So another key driver why we need to move away from this current infrastructure. So talk a little bit more about our use of FHIR in the project. We're working with HL7 UK and our teams with NHS England to develop a set of pathology-specific FHIR profiles. FHIR gives you a base set of resources which can be tailored by a process called profiling, and that's essentially what we're doing. So we're taking the 4 lab-related profiles listed there and customize them for our use. And we're also reusing some existing profiles that reference those lab profiles, the organisation, patient, etc. down there. And on the right side, we can see an example of an observation profile populated with data. Key things to point out here is that the test is coded as an observable entity. There are various references to other profiles that make up the overall test report. So we've got a link to the subject, i.e. the patient, to the organisation that performed the test, the specimen, etc., and also the result itself, which in this case is a numeric value. Okay, so just try and put the use of FHIR profiles in a little bit more context. So we're going to example report on the left, around the diagram illustrates the high-level relationships between the various profiles, which is very intuitive. So even though we've got the diagnostic report, the profile, which links to the service requests that it's based on, and then the report itself has the results that make up that report. In this example, it's just a simple result with a coded value for a negative. And all of the things you'd expect to appear on the report, obviously the specimen, the patient, the practitioner that requested the test, and the organisation that performed the test. I won't talk about this slide in much detail. It's just to illustrate actually quite a lot of links between the various FHIR profiles. This is the full set of links. It's obviously going to be available in the slide pack for you to look at as a reference. Okay, so just moving on, I mentioned at the start that I was going to explain various test report design patterns, how we're starting those using a combination of FHIR and SNOMED. So if we start to look at those. So this is the report we just looked at, a very simple Hep B report with a negative result. And this is a variation of the diagram we just looked at as well. This version has additional content to illustrate the use of SNOMED. So let's look at that top right-hand annotation there. That illustrates that we're using SNOMED procedures for the requested test. The specimen itself is a SNOMED specimen, nice and easy. The observation is coded as an observable entity. And in this case, because the result has got a coded value, we're also using SNOMED to support that, but that's a qualified value. So, second design pattern, slightly more complicated, is quite a common scenario in pathology, where you can provide a test group, also known as a panel or a battery or a profile. In this case, liver function test group made up of 4 test results. So the key difference here is we've introduced the idea of a group of observation, indicated by the slightly darker blue element there. That's coded in SNOMED using the SNOMED CT procedure. And it links to the test results using these has-been relationships, and they're coded using observable entities. So I've just picked out one there to illustrate the usage. So that's the key difference. We're using this group element. It doesn't contain any direct results itself. It just links out to the child elements that do contain the results. And then final example, this is a more complex report, microbiology reports, very similar to the EDIFACT example we looked at previously. And this carries the idea of using groupers to the next level, really. So here we've got multiple nested groups to define the structure of the report, all fully atomic, unlike the EDIFACT equivalent. Okay, so I'd like to talk a little bit about implementation and our approach for that. So this is a version of the slide we looked at previously, slightly updated. We are working with a laboratory partner, laboratory to develop a pilot to test our products before a national rollout. So we're working with that laboratory and their network, and also their suppliers to, as I say, test our products. The basis of that pilot and the initial interim implementation approach will be centered around the existing middleware, highlighted in the box at the bottom right there. So that middleware will be updated to output FHIR and SNOMED. So that's alongside EDIFACT and READ. It will be transported initially, probably using mesh as is now, and then sent to the GPP practice system. Keep pointing out there is initially we're going to be using the SNOMED CT PBCL code list. So if you remember, that's that sort of well-grained set of codes. The idea behind that is to lessen the impact on suppliers, because effectively that's what sort of the GP system they're mapping to now. Flowing SNOMED at that point moves the need for the GP system to make that when we consume the test reports. So that's a key difference. When we can see the code fragments either side and illustrate that process. This slide illustrates an interesting feature of FHIR. It can carry multiple codes to representing, using different code schemes. So this is a bit of a controllable example. We wouldn't really do this in practice, but it illustrates how you can support parallel codes in the same observation. So we've got a local code here, recode equivalent, and then the 2 flavors of SNOMED codes. As I say, we wouldn't do this in practice. It's likely, certainly for the pilot, we would flow that third code, the SNOMED CT PBCL code, from the middleware back to the GP practice system. This is another feature of FHIR. If we chose to do so, and may initially as part of the pilot, we could effectively downgrade the use of FHIR to carry blocks of text in a similar way as EDIFACT for more complex reports. So depending on the capability of sending and consuming systems, we could do this initially as an interim approach to implementation. So you can see there that the body of the report is actually carried as a string in the same way as we do in EDIFACT. So it does give us that option if need be. Okay, that's the end of the presentation. In terms of our next steps as a project team, so we're working with HL7 UK to finalise and improve the pathology profiles. As I say, we're planning to run the proposed data pilot I talked about. The output from that will help us inform the design for our actual implementation approach. And alongside all of that, we're going to publish a new information standard to support and enforce the implementation of our products. The final section there is a set of hopefully useful links to some of our work. It's our website, a link to the FHIR implementation guide, the UK core guide, which is a parent of that. And then finally, the rest of the new websites that contain our new procedure codes and other entities. That's it for the formal presentation. I'll be happy to take any questions if anybody has any. Thank you.
Hi, this is Rob Housen from the US, and I work a lot with HL7 Orders and Observations work group, and we're doing having a lot of discussions right now about the lab report modeling in FHIR. And I was kind of intrigued by your the way you described the way that you're doing it, particularly with the panels and the use of observations as a grouper and all that. There's been a lot of discussion back and forth about the pros and cons of that approach and all that. I wonder if you could say any more about your thoughts behind that, about what led you to that particular design decision, and any pros and cons of that approach, or any others that you considered.
Yeah, it's a good question, Rob. We're not sure if we're aware.
We're not hearing. Might be on mute.
Do you need me to unmute? Do you want me to unmute?
I don't think it's you. It's this side.
Try now, Phillip. I did unmute. See if that
Okay. Is that better? Can you hear me now?
No.
I'm not on mute this side. Can you hear me now?
Technical hitch.
Is that better? Yeah. Yeah, really good question, Rob. That's the design pattern we've chosen so far. We believe it provides quite a flexible approach, especially for more complex reports. However, we're aware of discussions going on within HL7 Europe that's looking at potentially an alternative approach. One of the benefits of that approach is it could provide sort of better backwards compatibility to HL7 V2. So these are all sort of key things we want to feed into our pilot, so we can learn the lessons from that initial implementation. So certainly that's the approach we're taking so far. We're aware of other approaches, and we'll hopefully learn from that and reach out to the wider FHIR community for advice as we go along.